Okay, so today we need to talk about bearing. So what makes bearing different is the fact that north, if you look here, north is 0 degrees. North is straight up. And so one of the reasons I bought these crazy little circular protractors has to do with bearing. In fact, if you look, this protractor has two sets of numbers, okay? If we're doing triangles, I would zero out here, okay? If we're doing triangles, put 0 here, and I go, 45, 90, that kind of thing, right? But if we're out in the woods, or if we're hanging out in my fancy yacht, we would look at a compass. And if we looked at a compass, we would notice that 0 degrees on a compass is right there. And then if you look at a compass, compasses rotate this way, right, Gaddis? You've been out in the woods with a compass, I'm sure, lots of times. So when we do bearing, the only difference is the rotation, all right? So 0 degrees is up here. So when you use these protractors, if it's bearing, put 0 at north. So put 0 right there. And then what we see is east is 90, south is 100, 180, and west is 270. So the rotation is going to be clockwise versus if you do a triangle, you put 0 here and you rotate the other way, right? That's the only difference. So let's go ahead and take a look at this. So one way we can talk about bearing or direction is to describe it this way. So north. So we're pointing straight up north. So if we're some dude out in the woods, we'd look north, and then we might turn ourselves 30 degrees towards the east. That would be our direction. Okay, so to draw that, I'm going to put north at 0. Okay, so on my protractor, I put north at 0 because I'm doing bearing, and I rotate 30 degrees towards the east. So I'm going to put a little mark here at 30 degrees, rotate to the east. So I look north and rotate 30 degrees to the east. That's what that says. Look north, rotate 30 degrees to the east, and we would be walking in this direction. That's our bearing. We know that this is a 30-degree angle because we rotated 30, and that would make this a 60-degree angles because it'd be 90 degrees between north and east, right? You could also look south. You could look south, point south, and you could rotate towards the west. So I'm looking south in the woods, and I wrote 25 degrees towards the west. I'd be going in this direction, right? So let's just zero our protractor out to 0 at the south. So take the protractor, and I'm going to put 0 down here at south. So I got south at 0, right? And I'll rotate towards the west 25 degrees. I'll put a little mark here. And I'll draw 25, and I'll draw that in, okay? So I know I'm going to point south and rotate 25 degrees towards the west. So I'd be heading in that direction, right? I'm looking south, and I go 25 degrees towards the west, okay? Let's see, this angle's got to be a, 65? Because I know together it makes 90, right? Now sometimes we just give it as a full rotation. Sometimes you can be given bearings full rotation. So if I'm on my boat and I wanted to spin it all the way around 300 degrees, it would go to right about there. That's another way to do bearings. So I take my fancy yacht that we're all hanging out on, and I'd zero it out. Okay, 0 up here, 0, 10, 20, right? See the 0, 10, 20. And I'm going to spin it, Garrett. I'm going to say, first mate Garrett, swing her about to 300 degrees, and Garrett would swing her about 300 degrees, all the way to right about there. We'd be heading that way. It's another way to describe bearing. Okay, so we really have 3 different ways to describe our direction. One is pointing north and having a rotation. The other is pointing south and have a rotation. And the other is just using the full rotation. Okay, 300 degrees went all the way around. 0, 180, whoops, 90, my bad, 90, 180, 270, all the way to 300, which makes this a 30-degree angle, and that's a 60, okay? We could have described this one also as north, 60, west. Same thing. North, 60, west. Okay, same thing. Okay. Now, how does that help us? Well, let's take a little trip, okay? We're going to go out on our little yachts here. So two ships leave port at the same time. Ship A travels, that's the Alondra ship. So the Alondra ship travels 8 knots on a bearing of north 35 east. So Alondra's kind of heading that way. Okay, she's going north but 35 degrees to the east, right? And then ship B, let's see, is that ship Becca? The USS Miss Becca is traveling at a bearing of 10. We're going to go south 10 east. So Becca's kind of going, she's going to look 10 and she's going to go 10 degrees to the east. So she's kind of traveling this way, right? She's looking south but 10 degrees towards the east. So it's really important to read it first, because if I were to try and put port right here, put port right here and draw my triangle, it's going to be off my paper. That's kind of silly. I kind of know where I'm going. So let's put port right about here. Let's call that P for port. Let's call that P for port. Put it here because I know I'm going that direction and that direction. And then I'm going to look at my compass. So I'm at port, and let's look at my compass. So I'm going to draw in. Oh, I like to call it the compass rose, but let's just draw in our compass. Okay, so that we've got our, our north here, our east, our south, and a west. Okay. All right. So Captain Alondra is going to take us on her boat. All right, Mr. Davies, at the helm. I want you to turn our boat north 35 degrees towards the east. So, aye, aye, Captain. Okay, so there's my north, 0. I'm going to go 35 degrees towards the east, right there. All right, Captain Alondra, we're heading that direction. We're going to look north. We're going 35 degrees towards the east. And I'm going to go 8 knots. So to make it easy, I'm going to draw it 8 centimeters. Okay, so I'm just going to take my ruler and draw it 8 centimeters. So there we go. There's my USS Alondra. Okay. So let me put some numbers in. This was 8. Because I drew it 8 knots. Knots is like a speed. It's a boating speed, nautical miles per hour. And then I know this is a 35-degree angle. So that means this would be a 55. I want to put every number I can in to help me solve this, okay? So that's 35 degrees, that's 55. I know because it's 90, right? All right. The USS Becca says, hey, Mr. Davies, grab the helm. Turn us about south 10 degrees towards the east. Now, Becca's heading south. She's thinking more tropical. Okay. Alondra's thinking maybe she wants to see the northern lights. You're going up north, okay? So we're going to go south, 0 degrees, right? There's my south. And we're going to turn about 10 degrees, just 10 degrees towards the east. So I'm going to go that direction. I'm pointing south, go 10 degrees towards the east. See it? Pointing south, 10 degrees towards the east, okay? And then we're going to go 6 nautical miles per hour, so I'm going to draw it 6 centimeters. Right about there. Okay. This is a 10-degree angle, so that means that's an 80-degree angle, okay? There's Becca, okay? So, after 1 hour, they're heading off in different directions, aren't they? They're going to go for 3 hours. And then just relax and chill, and then they're going to miss each other and say, oh, how far apart are we, okay? So for 3 hours, if Alondra continues, Alondra's going to go a total of 24 nautical miles, right? Because she's going to go for 3 hours. And the same thing with Becca. She's going to go for 3 hours, so she's going to be gone a total of 18 nautical miles, okay? So Becca's 18 knots away, Alondra's 24 knots away, and they say, wow, how far apart are we? I miss Becca. And Becca's going to say, I miss Alondra. So what they do is they know a little bit about right triangle trig, right, girls? So it's okay. Let's take a look at this triangle. So we look at our triangle trig, and we notice that we really do have a triangle in here, okay? So we do a little math, and we figure that angle's got to be 135 degrees, right? Okay, that angle's got to be 135 degrees. And they want to find out how far apart they are. Call that C. Okay. Give you a second to catch up. Draw it.
Did you hear that? Let me go investigate.
Okay. No, we're still live on film. Okay. Okay. You ready? Grace, are you ready? All right. So what do I know? Do I have a pair of opposites? No. But I do have side angle side, don't I? I've got a side angle side. I do have side angle side. So if I have side angle side, I can use law of cosines, right? I've got side angle side. I can use the law of cosines. C would be the opposite, right? So let's just set up our law of cosines. We're going to go, Arthur, put the phone away. We're going to go c squared equals, okay, adjacent squared, 24 squared, plus the other adjacent squared, 18 squared, minus 2 times the adjacent, which is 24, times the other adjacent, which is 18, times the cosine of my angle, which is a 135-degree angle, okay? So we're just setting up the law of cosines. I'm going to go ahead and go 24 squared plus 18 squared minus 2 times 24 times 18 times the cosine of 135 degrees, okay? And I get an answer. I have c squared is equal to 1,510.94 blah, 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 blah. But that's c squared, right? And of course that answer doesn't make sense. They're a long ways away with that answer, so we square root it because it's c squared, right? So c is equal to the square root of that. So square root of 1510.94 blah, 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 blah. Let's find out what that is. So let's see, what is the square root of that answer? We get about a 38.87. And that does make sense. 38.87 knots, okay? That's not that bad, is it? So it's the same stuff we've been doing. It's nothing new except for just how to draw it, right? And the way you drew it, we had to use this whole bearing thing, okay? I'll wait for you to get caught up and we'll turn the page, okay? Okay. Turn the page. All right. Okay. Number 2. Draw a two-scale triangle ABC. If angle A is 30 degrees, little b is 6, and little a is 4. So, okay, so if I got to draw a triangle, let's start with angle A. So I'm going to put a point here and call it A. And if I need to draw an angle, let's just give it a terminal side. So let's start there. I need to draw a 30-degree angle. I'm going to start there, okay? So I put a point for A and drew its terminal side. And then I'm going to use my protractor to find that 30, okay? So I put my protractor down. 10, 20, 30. Make a little mark, right? I need this to be little b. I need this to be 6, okay? So I need to draw that in 6 centimeters. So I'm going to use my ruler. And I draw it in 6, okay? So there's little b is 6, okay? There's angle A, which is 30 degrees, okay? Grace. No. 30 degrees. All right. So now I need to draw in little a, and little a has got to be opposite, so I draw in little a, which is 4. Let's see, and it fits right about there. Right about there, okay? All right. However, Hayden says, hey, Mr. Davies, I think it could also fit there.
Exactly what I was thinking.
Which means there really are 2 possible triangles. 2 possible triangles. Okay, I'm going to say, wait, Hayden, wait. Okay, I see there are 2 triangles, but let's find the big triangle first, and we'll go back and look at the little one, okay? So first, let's solve for the big triangle. So over here, let's solve for the, I call it the big triangle, okay? So the big triangle, if this is side B, this has got to be angle B, which makes that angle C, and makes this little c, okay? So it does have 2 possible triangles. Let's solve for the big triangle first, and we'll go from there, okay? Now, anytime I have a pair of opposites, I like that because the law of sines is the easy one, right? Law of cosines isn't hard, just bigger, that's all. So, and I do have a pair of opposites. So if I have a pair of opposites, I want to use the law of sines, right? So I've got my 4 and my 30, I have a pair of opposites. So if I use my 6, I could find my angle B. It's opposite. So I've got opposite, 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 right? So let's go ahead and use the law of sines. I need to find the angle. So if I need to find the angle, I'm going to use this one right here, the sine of theta over opposite one. So I'm going to set up the law of sines. I'm going to go sine of B over 6 equals sine of 30 over 4, okay? Sine of the angle over its opposite side equals sine of the angle over its opposite side, right? Multiply up the 6, right? So it goes sine of B is equal to 6 times the sine of 30 divided by 4. And I'll use my calculator as soon as you're ready, okay? So I'm just setting up the law of sines. Use my calculator real quick. So I'm just going to go 6 times the sine of 30. Close your parentheses, divided by 4. And I get a decimal, right? I do get a decimal because when I need to find the angle, Grace said it earlier, you need to use the inverse button, right? You got to use the second button. So now I have to go sine inverse of this 0.75, which I do, sine inverse of that answer. Yeah, I'll round to 0.6. Yeah, very good. 48.6. Okay, so angle B is a 48.6 degrees. Okay, 48.6. Okay, good. I got an answer. Now, angle C is easy, right? Because I know in a triangle, 180 degrees in a triangle, right? Am I going too fast? Okay. Okay, so angle C, right? 180. Add them up. So angle C would equal the 180 minus my 30 plus my 48.6, right? That's just geometry stuff, right? So I'll go 180 minus my 30 plus my 48.6, and I get an answer of about 101.4. So I get 101.4. And then finally, let's find little c. And again, of opposites. I've got my pair of opposites. So let's find little c with my opposites, right? Opposite, 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 opposite. We'll go little c over the sine of its angle. 101.4 equals the 4 over the sine of 30. Okay. And I'll cross multiply, bring that up here. So little c is equal to 4 times the sine of 101.4 over the sine of 30. Okay, and I can just use my calculator, which I will. Clear that. 4 times the sine of 101.4, close parentheses, divided by sine of 30. And I can answer about 7.8. Okay, so little c is about 7.8. Okay, not bad, right? Everybody okay on all this? Okay, it's just using the law of sines. That's not bad. Okay. Now, however, we could have drawn another triangle. In fact, if let me borrow this ruler because you can see it better this way. Thanks, Michaela. So 4 could have also been drawn right here. Do you guys see that on my picture? That if I had followed the direction, got a 30-degree angle, 6, I could have drawn this side for it, which would make a completely different triangle. In fact, the triangle I'd be looking at would be this one right here. Okay, so I could have possibly had this triangle. Both triangles are correct. Both triangles are correct. Which one's right? They're both right. So we got to solve for both. So let's solve for the obtuse small triangle. Okay? How do I do that? Well, here's the trick. Okay? Everybody, here is the trick. Don't forget this. Every single buddy, every person in the room, watch. Here's the trick. These two angles are equal. This angle is equal to this angle. Has to be, because that's 4 and that's 4, okay? Now, this is not the triangle we're going to solve for, but these two angles have to be equal. If that's 4 and that's 4, then base angles are equal. So that means that this angle right here is also 48.6. That's not the angle I want. What I really want is this angle right there, right? I don't really want that angle. I want that triangle, but that's going to help me, right? These two angles are supplementary. So And angle B is no longer here, is it? Angle B is right there because I'm only looking at that triangle. So angle B is really here. So I want to find angle B. Well, that's easy because you're just going to subtract from 180. So angle B over here is just going to be 180 minus my 48.6. So all I'm going to do is take 180 and subtract from the angle B over here. That's all I'm going to do. So what is that? I don't know. So calculus made for 180 minus 48.6. Yeah, 131.4. So angle B is 131.4 degrees. Okay, now at this point, I'm going to do the exact same steps, except for different numbers, right? So if I set up to find angle C, I am going to add up and subtract from 180, except for I'm going to have a different answer because it's much smaller, right? So angle C is going to be the 180 minus my, well, 30 plus my 131.4. Use my calculator. Let's see, 180 minus the sum of 30 and 131.4. So angle C is about 18 degrees. About 18.6 degrees, okay. 18.6 degrees, okay. And little c is no longer all the way over here. Little c is, because we're only using this little triangle here, little c is just this little side here, okay. But we're going to figure it out the same way we did here, same step we did here, except for a different angle. So we'll go little c over the sine of its opposite angle, which is the 18.6, right? Little c over 18.6 equals the 4 over the sine of 30. The 4 over the sine of 30. So it's the exact same process as what we did on the other side. The only difference is that we're using different angles, okay? Multiply by 4. I'm going to get c is equal to 4 times the sine of 18.6 divided by sine of 30. Just going to use my calculator, right? I'm going to go 4 times the sine of 18.6, close the parentheses, divided by sine of 30, and I get an answer of about 2.55. Okay. All right. Page 975, 1 to 11 all, and we've got lots and lots of time to get it done.